All right, in this video, I'm going to be showing you multiple functions and stating the intervals of increasing and decreasing. A couple things to keep in mind that whenever you state the intervals of increasing and decreasing, you're only looking from left to right. So the best word I can use is the word scan. So you're going to do that with your eye. You're going to scan the graph, but you're going to start from as far left as you can go. So you're going to start here, and you're going to travel from left to right. So I'm going to be showing you multiple functions and graphs to give you a different perspective on to compare and contrast different types of functions. Okay. Another thing that may be helpful is to think of this in terms of gravity or like a roller coaster. So if you were on a little roller coaster here, this little car, and you're traveling from left to right, you're going to be climbing. You're going to be going uphill. Okay? So this function here, this is a linear function, y equals mx plus b. The slope is 2. The y-intercept is 4. And this function from left to right, if you start out from left to right, this thing's going uphill. And it always was going uphill, and it never will stop going uphill. So we would say that it's increasing from negative infinity to infinity. And this is speaking about left, and this is right. So in my previous videos, I communicate to you that there are different types of infinity, or different directions of infinity. There's up. Up is also an infinity direction, and right is also an infinity direction. But interval notation, you're only thinking from left and right, west to east. So in this case, this infinity here would be speaking about to the right. And then this function is never decreasing, so we would just say empty set, or just write it's never decreasing. Just a quick thing here without doing another graph, but if I were to put a -2 here, put a -2 as a slope, the graph would be going down. Okay, the slope would be going downhill. The y-intercept would stay at 4, but the slope would be going downhill. In that case, these intervals would be flip-flopped. It would not be increasing at all. It would only be decreasing. So linear equations are either always increasing and never decreasing, or it's never increasing and always decreasing. It depends upon the slope. And it would be cool if you can just look at the slope of an equation and see it in your head without actually graphing it and know if it's going uphill or downhill. All right, now this one here, this is a parabola. And once again, let's use the roller coaster analogy. So here's your little roller coaster ride, and you're traveling from left to right. Now you start out this journey going uphill. You're climbing up this elevator, or this roller coaster. And this thing does not have a beginning. So you are increasing from negative infinity, and you stop going uphill at -1. Okay? You stop going uphill at -1. So we're only looking at the x values here. Only the x values. So this thing gets cut in half here. Now once you hit the peak here, you start to go downhill. Okay? Downhill. You start to decrease from left to right. So from -1 to positive infinity. This is to the right. So even though the graph is going down, so you may say, okay, well, you're free falling here on the roller coaster, you're going down, but that is a y direction. When you do intervals of increasing, decreasing, you're only scanning from left to right. So even though this thing is falling, it's also traveling to the right forever. So that's why we end up at infinity to the right. Okay? So uphill, hits a peak here, and then starts to go downhill. We don't use the number 4 here because that is a y value. We're using the x value here because that's where it stops. Okay? On to the next one. Here we have two different functions. This is the parent function, square root of x. The plus here, plus 4 here, actually is going to move the graph to the left 4 units. And it goes like that. So in this case, this graph has a beginning. It has a little point. This is where you get on the roller coaster. Now, if you get on the roller coaster here at -4, you have a seat, you put on your seatbelt, and you start traveling from left to right. You start going this way. You're going up, up, you're climbing, climbing, and this graph never stops going uphill. Okay? So this graph is never going downhill. It's never decreasing. It's only increasing. But it starts to increase from -4, and it never stops. Okay? -4, never stops. A quick little observation here, and this is a real subtle thing I don't really care much about. Even though the graph starts at -4, the reason why we don't put bracket on the -4 here is actually there's a physics reason. And let me try to reason with you this way. When you get in the roller coaster and you put on your seatbelt and they're giving you the directions, keep your arms and hands inside the cart, are you moving at that point? No, you're not. You are stationary. You're in the roller coaster. You're putting your seatbelt on. They're giving you directions. You're not increasing. You're not decreasing. You're not moving. So at -4, you're not going uphill or downhill. You're stationary. So we technically don't put the bracket here on intervals of increasing, decreasing. You're never going to put a bracket. It's always parentheses. Okay? But if you happen to put brackets for one of my assignments on increasing, decreasing, not a big deal. I'm not concerned with that. I'm concerned about the values in the intervals more. All right, let's go to our semicircle here. Here it starts at -5, and it starts to go uphill. You start to climb, climb, climb. So that's increasing from left to right. Okay, so it's increasing. And once again, we're going to not use a bracket there because we're starting at -5. We're getting in the roller coaster, putting on our seatbelt, but we're not technically moving. We start to go uphill until we hit here, and the x value at that maximum point is 0. Okay, once again, we only use x values in the intervals. So from -5 to the x value of 0, we start to go uphill, and then we start to go downhill from 0, decreasing from 0 to +5, and the roller coaster stops. Okay? And I think there's one more graph. Oh, there we go. So first of all, this rose function here, this pink one, and this rose-looking graph, that's the parent function. The -2 just is going to move the graph down 2 units, which is what I did here. So the thing got shifted. So looking at this graph, it starts to be concave up like that, and does like a little dipsy doodle, and it goes concave down. Okay, so even though the curvature of the graph changes from here to here, I want you to think about the roller coaster analogy. So if you're traveling from left to right, you start forever to the left, and you start to go to the right. You start to travel to the right. Even though it's curvy up, you're going uphill, right? You hit this dot here, and it's like a little bump in the road, but you're still continuing to climb. So even though the curvature of the graph changes, this is increasing. It hits a little bump here, but it's still increasing even though the curvature changes. So this function is always increasing. It doesn't have a beginning, -infinity, which is forever to the left. It hits this bump and it goes forever to the right. So it goes forever to the right, okay? And this function is not going downhill at all. You're always climbing from left to right.